Hello, welcome once again to my channel, my physicist channel, where we solve problems on physics, different concepts on physics, and explain the principles and concepts of physics. Okay, we have another problem before us to explain, and so that those that are struggling with how to resolve circuits, especially complex circuit like this, we have a clue on how to go about it. Okay, look at the circuit we have here. And then the question is that we should find the readings of the ammeters, the readings of these ammeters, this ammeter here, the readings on this ammeter here too, and the reading on this ammeter 3. So we are to find the readings of the ammeters A1, A2, and A3. So we go this way. To solve this kind of problem, we need to understand something. We need to understand that this circuit has a total voltage supply of 40 volts. A total voltage supply of 40 volts. And then out of these 40 volts, this particular resistor here has taken 24 volts. 24 volts. So out of 40, what is remaining? The remaining voltage goes to this component, the whole of this. And then if we do that, we have a total voltage supply of 40 volts. And then this 40 volts is supposed to be the voltage that goes across the R and the voltage that goes across the whole of this. Let's take the whole of this as K. So it's going to be the voltage across K. So if we do that, if our voltage supply is 40 and the voltage across R is 24 volts, then plus voltage across K, if we solve this, our voltage across K, that is the whole of this, is going to be equal to 40 minus 24, and that will give us 16 volts. 16 volts. So this voltage, the voltage across the whole of this component is 16 volts. So this is 16 volts. We are getting that. Now the next we are going to do is, remember this component, this region here has these following resistors connected. I have this 10 ohm resistor connected here, and then I have this 10 and this 30 ohm resistor connected here. You see how the circuit is connected. So if you look at this circuit here, you see that the 10 ohm resistor is connected in parallel. This 10 ohm resistor is connected in parallel with this other 10 ohm and this other 30 ohm. So the implication is that if electrical devices are connected in parallel, they have the same voltage across them. They have the same voltage across them. So in that case, the voltage across these two resistors here is 16 volts. The voltage here is 16 volts. That is voltage here. So if the voltage across these two resistors is 16 volts, we can actually find the value of the current here. And then how do we do that? We do that using Ohm's law. Remember, Ohm's law states that voltage is equal to current times R. So if I make current the subject of the formula, I'm going to have that the current is going to be the voltage over R. But mind you, please, this R here is actually the total resistance between these two resistors. And for these two resistors here, I have 10 ohms, and then I have 30 ohms connected in series. You can see the 10 ohm here, 10 ohm resistor, this is 10 ohm, and then I have this 10 ohm here. I have 30 connected in series. So if I find the total resistance here, so this my R here is actually going to be equal to 10 plus 30. That is resistors connected in series, and that gives me 40 volts. 40 ohms. So this gives us 40 ohms. 40 ohms. So the total resistance between these two resistors is 40 ohms. 40 ohms. So if we apply this formula here, if we apply this very formula to find the current that I2 is going to read. So A2 is going to read. So let me call it I2. There's current across the second ammeter. And I substitute my value. Remember, we got that the voltage across these two resistors is 16. So I'm going to have 16 divided by, and then this is what? 40. Okay? 16 divided by 40 is supposed to give us 0.4. 0.4. This is supposed to give us 0.4 amperes. So we conclude that A2, the current across A2, which is ammeter 2, is going to read a current of 0.4 ampere. That's the current is going to read. Okay, so the next thing we do is to find the current that A1 will read and the current that A2 will read. Now remember, A1 and A2 will record the same current. This ammeter here and this ammeter here will record the same current, and they are going to record the total current in the circuit. So by finding the current, the reading of A1 and A3 rather, what we are doing is to find the total current in the circuit. And let's see how we can find the total current in the circuit. Let's see how we can find the total current. Let me minimize this. The total current in the circuit. Now let's go. From what we have done, we have seen that A2 is going to record a current. A2 is going to record a current of 0.4 amperes. A2 is going to record this current 0.4 amperes. This is what A2 is going to record. So that means the current here is 0.4 amperes. Now look at what happens. This is the positive terminal of this battery. The positive terminal of this battery is here. So current flows like this. Current flows like this. When this current gets here, this is the direction of flow of current. When this current gets here, it's going to divert like this. So there will be current coming like this. This one is going to divert like this, to go like this. There will be current going like this. But at the end of everything, the two currents will meet here. The two currents will meet here. That means at this point here, the current I'm going to have at this point, current at this point, is going to be current coming through this region. The current coming through this region, which we got at 0.4, plus the current passing through this. The current passing through the upper 10 ohm resistor. So we say current across the 10 ohm resistor. So that will give us the total current in the circuit. That will give us the total current in the circuit. So the next thing to do is to find the current that passes through the 10 ohm resistor, then add it to 0.4. Okay, let's do that. To do that, we still apply the Ohm's law. Current is supposed to be voltage over resistor. We have already seen that the voltage that passes through this 10 ohm resistor is 16, because this region here, please let me clear so that we see. Because this region here, we have this region and the 10 ohm resistor are connected in parallel. So that region and this region, they are connected in parallel. So if 16 volts passes through this region, 16 volts also pass through this region. Therefore, the voltage across the 10 ohm resistor is also 16. So we divide 16 by the resistance of the 10 ohm resistor, which is 10. So this gives us 1.6 ampere. Okay. Now the total current in the circuit, according to this formula here, the total current in the circuit, total current, let's say I total, the total current in the circuit is going to be 0.4, which is the current across this branch of the circuit, plus the current across this branch of the circuit, which is 1.6. And then we are going to have 2 amperes. We conclude therefore that A1, with this information, we conclude therefore that A2 measures 0.4 amperes, A1 measures 2 amperes, A1 measures 2 amperes, and A3 also measures 2 amperes. That is how to answer this question. Thank you very much for watching. If there's any question, anything you don't understand, you are free to comment in the comment section. Thank you very much.